Okay, in this video, I am going to go over how to do a couple of stoichiometry problems. Stoichiometry is that part of chemistry that tries to show some relationships between, and quantitative relationships between the reactants and products in a chemical reaction. And so you see we have this chemical reaction here, sodium hydroxide plus sulfuric acid or hydrogen sulfate produces water and sodium sulfate. Water, sodium sulfate. And it's asking how many grams of sodium hydroxide are needed to produce 3.1 grams of sodium sulfate. I'm sorry about the sodium sulfate. It's not the correct format, but I'm going to rewrite this because it's the first step that we need to do before we begin a stoichiometry problem is to make sure that the equation or the reaction is balanced. And so what I'm going to do is I'm just going to go ahead and write this out. NaOH plus H2SO4 produces H2O plus Na2SO4, sodium sulfate. And to balance, I'm just going to put a line there between the reactants and products because I want to know that I had the same amount of atoms in my reactants that I have in my products. And so then I'm just going to list these. And I always put them in the same order so I can just look across and make sure that I had the same amount when I'm done balancing. And so for sodium, we have one sodium atom in the reactants, and for the products, we have 2. For the reactants, oxygen, we have 1 here and 4 here, so that gives us 5. And over here, we also have 5, right? For hydrogen, we have 3 on the reactant side, and we have 2 on the product side. And for sulfur, we have 1 on each side. So I'm going to look at my metals first. You always want to, usually, you always want to balance those first. And so since I have 2 on the reactant side, I'm going to put a 2 coefficient in front of the compound that contains sodium on the reactant side. And that's going to change the sodium to 2, but it's also going to change the oxygen. Now we have 4, 5, 6 oxygen, and it's also going to change the hydrogen to 4. Okay, so now let's do sulfur. Sulfur is already balanced, so let's move on to hydrogen. Hydrogen, we have 2 on the product side, and so I'm going to put a 2 in front of the compound with hydrogen. And now we have 6 oxygen and 4 hydrogen, and it's balanced. Okay? And so we just used 2 coefficients right here and here. And so now we can move on to the next step. So you can see that the format didn't come out very well on this slide. So again, I'm just going to rewrite it. 2 NaOH plus H2SO4 produces or yields 2 H2O plus sodium sulfate. Okay, so the first thing you want to do is always start with what you're given. So it's asking how many grams of sodium hydroxide are needed to produce 3.1 grams of sodium sulfate. So we know that they're giving us 3.1 grams of sodium sulfate, and we're always going to start with what we're given. And so we're just going to go ahead and write 3.1 grams of sodium sulfate and we're going to put that over 1. I always tell my students, always start with what you're given and use dimensional analysis, because then you can make sure that all of your units cancel. It's just that you just need to figure out what conversion factors you're going to have to use to get to where you want to go. And so where we're going in this problem is to grams of sodium hydroxide. Okay? So we're going from grams of sodium sulfate to grams of grams of sodium sulfate to grams of sodium hydroxide. So now, to get to grams of sodium sulfide, or sodium hydroxide, we're actually going to have to we're going to have to use the molar mass, so we can get moles of sodium sulfate, and so that we can do a mole-to-mole ratio between sodium sulfate and sodium hydroxide. So we're going from grams of sodium sulfate, right? This is our given, to moles of sodium sulfate, and then we're going to go to, we're going to use our mole-to-mole ratio so that we can get to moles of sodium sulfate. So we use our mole-to-mole ratio, and then we're going to do our molar mass, of sodium hydroxide, and that's going to give us grams of sodium hydroxide. So let's keep moving here. So we have to set up this next conversion factor so that grams of sodium sulfate cancel and we get moles of sodium sulfate. So our conversion factor is just our equality, so we know that 1 mole of sodium sulfate is equal to 142.04 grams of sodium sulfate, right? And now you can see we can cancel grams of sodium sulfate and we're left with moles. And now we need to go, we need to be able to convert this to moles of sodium hydroxide. And so we use the mole-to-mole ratio. So we know that in the numerator, we need moles of sodium hydroxide. Whoops, that's not very good. Go back. And moles of Na2SO4. So up here, we look in the equation. So we have 2 moles of sodium hydroxide to 1 mole of sodium sulfate. And so we can put those in 2 to 1, right? And now we cancel out moles of sodium sulfate. We're left with moles of sodium hydroxide, and we know that we can use the molar mass of sodium hydroxide to get it to grams, right? So 40 grams of NaOH is equal to 1 mole of NaOH, right? And so our moles of NaOH cancel, and all we have to do now is multiply through. And so if we multiply through 3.1 times 2 times 40, we're going to get, and I'm going to put this down here, we're going to get 248, and then we're going to divide by 142.04, and remember this is grams of NaOH, and our final answer is going to be 1.75 grams of NaOH. Okay? All right. So let's move on. Oh, shoot. So, I do not know why it keeps doing this. Sorry. To this next problem. And, whoops. Didn't want to do that. This one is it's one of those percent yield calculations. So again, we need to make sure that we have our reaction balance, our equation balance. So I'm going to write it down here because this, or I can write it up here, I guess. It just didn't format correctly. So C6H6 plus Cl2 produces C6H5Cl plus HCl. Okay, and it's asking what the theoretical yield is if 45.6 grams of benzene reacts. So benzene, this is benzene. So this is benzene, and the chlorobenzene would be this right here, okay? So the theoretical yield is the yield that we can get if we do the equation. This is the, in theory, this is how much chlorobenzene we should get, right? So what's the theoretical yield if 45.6 grams of benzene react? And so this is our given, and so that's what we're going to start with. We're going to start with what's given here, and that is 45.6 grams of benzene, C6H6. Okay, and we always put that over 1. Whatever we're given, we put it over 1. And then we're going to move on. So we always start with what we're given. I think I got muted there for a second, but okay. So we're moving on, and now we need to convert to moles, right? And then we'll use our mole-to-mole ratio. By the way, this equation is balanced, so we're good. So 1 mole of C6H6 is equal to 78 grams of C6H6, right? 12 times 6 plus 6. 12 times 6 is 72 plus 6 is 78. All right, so now we see our grams of benzene cancel, and we're left with moles of benzene. And now we'll do our mole-to-mole ratio. So again, this is our given. From our given, we're going to use the molar mass of the given, the compound that's given. that we start with. And so now we're going to do our mole to mole ratio, our mole to mole. Now, on this one, it doesn't really matter because our mole to mole ratio is actually 1 to 1, but I always like to put it in there just to make sure that I'm working the problem out right and I'm canceling the correct units and coming up with a correct answer. So we're going to do 1 mole of chlorobenzene. I can't even say it. C6H5Cl and 1 mole of C6H6, right? Okay, that's our mole. And now we just need to do our molar mass of what we're trying to find. And our molar mass of what we're trying to find would be the molar mass of chlorobenzene, which is 112.56 grams of C6H5Cl over 1 mole. And so let's make sure our units cancel. Mole of C6H6, mole of C6H6, mole of chlorobenzene, and mole of chlorobenzene, and we're left with grams, and which is what we're trying to figure out, right? And so if we multiply through 45.6 times 112.56, we get 513.7. Oh, let me erase that. 513 point, whoops, that's not right. Sorry, keep writing that wrong. So 5,000, how about that? 132.74 divided by 78. And that's going to equal 65.8 grams of C6H5Cl. So theoretically, this is how much we should be able to get. However, in the lab, we don't always come up with that amount. And so it tells us that the actual yield is 63.7. So in order to find the percent yield, we take the actual yield and divide by the theoretical yield. So the actual yield divided by theoretical yield would be 63.7 grams, right? And then divide that by 65.8 grams. And so your percent yield would be about 96.8%. All right, well, I hope this helped. Sorry for the little mistakes here and there, but I hope it helps. If you have questions, let me know.